next part of the video, we're going to go to Texas, primarily South Texas. In fact, at one point, we're going to go to what was once the U.S.-Mexico border, the Nueces River. Did not stay the U.S.-Mexico border very long. We had a war with Mexico, and then we won a big chunk of South Texas. Large bit of that is taken up by King Ranch. All the good stuff. Anyway, this ain't a history class, but does sometimes play into things. The Nueces River is an interesting choice for an international boundary. If you go there most of the time, there's hardly any water in it. You could probably walk across it most days. But every now and then, if you've ever been to Texas, you can go for like, 3 months without seeing a drop of rain. Then one day, it rains 30 inches in a couple hours. And it seems like the further south of the state you go, the more extreme this contrast between wet days and dry days becomes, even though on the whole state, South Texas is a little bit drier than North Texas by all measures. So it's this sort of pattern that leads to this very interesting channel geometry. Look at the pattern of channels. Which of these is the main river channel here? Curious now. Well, turns out they all are. When you get the following circumstances, variable flow rate, you're going to get variable flow rate, and capacity and load, and your load is actually going to be slightly often greater than your capacity. And you sort of alternate between these times when your load is greater than capacity and your capacity is then greater than your load. Load. Back again. You get a very interesting channel geometry. You get a river that during times of high water just pushes a lot of sediment downstream very rapidly. But because the rate of sediment flow is slower than that of water flow, as the flow rate drops after, say, a heavy storm, or if you're in a place with a lot of snow, as the sun goes down, all that sediment is going to start falling off right in the middle of the channel because the river just loses its capacity and all the sediment just falls out. You kind of think of this as coming home from the grocery store after binge shopping for the coronavirus apocalypse, and you're carrying a bunch of stuff and you keep dropping stuff. Make sure you don't drop the toilet paper when you do that. Then the subsequent channel that forms has to find its way around those deposits that the bigger river has dropped. And what it's going to do is it's going to split into a bunch of channels or braids, much like we're seeing with that river system in South Texas. You're seeing, it's the term we give this river system. We call it a river. Now we see these not only in South Texas and places that get high, very occasional freak rainstorms. We also see this in places where there's glaciers or large amounts of snow. During the spring and during the day, even the summer, sunlight hits the snowpack. The snowpack releases a lot of water into the river basin all at once, and the river swells up. There are certain places where they advise you to make sure to complete any planned river crossings before 9 or 10 in the morning in parts of Alaska, because if you try to cross that river in the late afternoon, it is going to be a lot more difficult. In fact, if you watch Into the Wild about that guy that died of starvation on a bus out in the Alaska wilderness, one of the reasons he couldn't get back to civilization was he did not understand the dynamics of the river he was crossing. And then as the sun goes down, you get less and less flow into the river, and the stream dies down. We're seeing this river looks like it's kind of full, but definitely not at flood stage. It could be a lot fuller. And so some of these islands might be fairly permanent features. Some of these are probably moving a little bit every day. Now moving downstream, you get into a regime where river is getting flatter and flatter. It's not getting too many things added to it. And so what starts to happen is you start getting these river starts to block its own path just because its load is now pretty much always greater than its capacity. So we start to see this sediment raining out of the river, and at this point, the river might actually be the highest point in the land surface. Yes, this is not a stable situation. A great place to witness this firsthand is the Mississippi Delta. So just take a look at this. From about this corner of the Mississippi-Louisiana state line to the mouth, it takes a long, tortuous, meandering route. It would actually be much shorter for it to cut off and head to follow the course of the Chaffalaya River through Morgan City, but it is confined by all those levees. And so if you look closely at places like New Orleans, Baton Rouge, but especially, New Orleans, what you notice is that by the point you get this far into the Gulf of Mexico, the river levees are the highest point on the land surface. In fact, pretty much all this land was deposited into the Gulf within the last few thousand years during one of the last course changes of the Mississippi River. And what we see is that every time the Mississippi River floods now, they are directing more and more water down what is known as the Chaffalaya River into through Morgan City, and that it is only a matter of a few decades at most before the Mississippi River jumps its banks at Old River Control Structure and finds a new way down to the Gulf of Mexico, leaving New Orleans high and dry and Morgan City underwater. In fact, to stop this, the Army Corps of Engineers has built the following set of dams that are about 20 feet high to prevent the Mississippi from jumping its banks and flowing into the Chaffalaya Basin, or at least limit the amount of water making it in there. But even during this, they still have several structures in place that allow the Mississippi to join the Chaffalaya during periods of high water. Another little structure they have here is just below, that's Baton Rouge. I know what's LSU. Just below Baton Rouge, they also have this thing, the Bonnet Carre spillway, which is easier to open. Yeah. You notice, a lot of these places are looking pretty precarious. You can kind of see it that, all the land surface here is lower than the banks of the river. So we call this area where the load is almost always greater than the capacity. We call it the delta. Pretty much that is the common feature of all deltas. There's even rivers that will form deltas in the middle of large flat plains, like the Okavango River in Africa forms a delta type structure. So in this case, let's do a little channel drawing as we can. It's fun. The river is sitting atop a deposit here. The river channel might actually be fairly deep, but the river is essentially sitting atop a pile of its own deposits at this point. And it really wants to break through these levees and flood the surrounding area. And pretty much is only a matter of time before that happens. If this seems like an exciting study, I encourage you to read John McPhee's A Control of Nature. So in the next portion of the lecture, we're going to go into how human activity has affected the flow of rivers, using an example from the Pacific Northwest, where they recently removed a series of dams.